When you type a prompt into an AI image generator, say a cat astronaut painted in watercolor, a picture appears a few seconds later, and it feels obvious what happened. The machine went and found some cat photos, some space photos, a bit of watercolor texture, and blended them into a clever collage. Almost everyone pictures it that way, and it's completely wrong. There are no pictures inside the model. None. It didn't go looking for anything. Here's what actually happens. It starts with a screen of pure static, random dots, like an old TV tuned to no channel. And then, guided by your words, it removes that noise, a tiny bit at a time, until an image that has never existed anywhere in the world appears out of the fog. That's the whole trick. It doesn't find a picture, it sculpts one out of noise. And once you see how that works, you'll never look at AI art the same way again. So let's take one apart. How it learned, how it draws, and where your words come in. And then answer the question everyone's actually arguing about. When it does this, is it copying? No hype, no doom, just how it works. Let's start with what it is not, because that's where the intuition breaks. When people imagine an AI making a picture, they usually land on one of two ideas. Either it's a painter, sitting at a blank canvas, adding brush strokes until there's a cat. Or it's a search engine, typing your words into some giant library of images, pulling the best matches, and stitching them together. Both feel reasonable, both are wrong. It isn't a painter because it never starts from a blank canvas, and it isn't a search engine because there's no library to search. The moment it makes your picture, the model isn't on the internet, and it isn't flipping through a folder of photos. All it has is a fixed pile of numbers. So here's the mental model that actually fits. Hold on to it for the whole video. An AI image generator is a sculptor. Its block of marble is a screen full of TV static, and your words are the chisel. It doesn't add a picture. It carves one out of the noise. Everything else we talk about is just how it learned to carve. So how does anything learn to carve an image out of static? By learning to do the opposite first. Picture a single training photo, a sharp, clear picture of a dog. Now sprinkle a little random noise over it, so it's slightly grainy. Then a bit more and more. Keep going, dozens or even hundreds of times until every trace of the dog is gone and there's nothing left but fuzz. You've destroyed the picture on purpose. That's called the forward process. And the clever thing is, it's completely mechanical. You're just adding static on a schedule. Now, here's the model's one and only job. You show it one of those half-destroyed images and you ask a single question. What noise did I just add? That's it. Not draw a dog, not understand a dog. Just look at the mess and estimate the noise sitting on top. And you make it play this game across an enormous library, hundreds of millions of image and caption pairs scraped from the open web. Do that long enough, and it gets frighteningly good at one strange skill. Give it a noisy image, and it can tell you exactly which part is noise, which means it can also strip that noise away. And that skill is the whole ballgame. If the model can pull the noise out of any noisy image, you can run the process backwards to make something brand new. So you don't give it a photo at all. You give it pure random noise, a fresh screen of static with no picture hidden inside. Genuinely nothing there. Then you ask, what noise do you see? It makes its best guess, you subtract a little, and the static gets slightly less random, a faint hint of shape. Feed that back in, ask again, subtract again, a bit more shape. Repeat this maybe 20 to 50 times, and step by step, out of what began as meaningless dots, a clean, coherent image assembles itself. And here's the beautiful part. That image never existed before. The model didn't store it and hand it over. It learned what real images tend to look like, how eyes sit on a face, how light falls on metal, and it used that to nudge random noise towards something that could be real. It's also why the same prompt gives you a different picture every time. Different starting static, different sculpture.
Change the random seed, change the block of marble, and you carve something new.
But hold on, if it's just removing noise toward a real-looking image, what makes it a cat astronaut and not a bowl of soup? This is where your words come in, and it's the part people get most backwards. Your prompt is never searched for. It gets translated into numbers by a separate piece called a text encoder. The famous early one is called CLIP, and it was trained on roughly 400 million image and caption pairs, learning to place a picture and the words that describe it close together in the same mathematical space. So CLIP already knows, in a numerical way, which direction cat points, and astronaut, and watercolor. Your prompt becomes a set of coordinates like that. And here's the key move. Those coordinates are fed into the denoiser at every single step. So it isn't removing noise toward just any real image. It's removing noise toward an image that matches your words. Your prompt doesn't fetch a picture. It steers the carving, like a target the sculptor keeps checking against. Change the words, and you change the target, which is why these tools can draw a teapot made of galaxies as easily as a plain one. No photo of that ever existed to look up. It just steered the static somewhere new.
Now, there's one problem with everything I've described, and solving it is what put AI art on ordinary laptops. Doing all this denoising directly on a full-size image is brutally expensive. A modest picture is hundreds of thousands of colored dots, and you're reworking every one dozens of times over. On a home computer, that would crawl. So the big trick behind Stable Diffusion was this. Don't work on the full picture at all. First, squeeze the image down into a tiny compressed summary, a kind of rough sketch, using a learned compressor called a VAE. This shrinks it about 8 times smaller on each side, which means dozens of times fewer numbers to push around. Then you do all the noisy back and forth in that little sketch space where it's fast and cheap. And only at the very end do you hand the finished sketch to a decoder, which blows it back up into a full detailed picture. Carve in miniature, then enlarge. That one idea is a big reason a wave of these tools suddenly ran on regular gaming PCs instead of giant data centers. The trade-off is that the compression is slightly lossy, part of why AI images sometimes fumble tiny details, like text on a sign or an extra finger.
If you've ever used one of these tools, you've probably touched 2 dials without knowing what they did. The first is steps, simply how many rounds of predict and subtract it runs. More steps, more polish, but slower. The second is guidance, how hard your prompt is allowed to steer. Turn it low, and the model gets loose and creative, but may drift off your words. Turn it high, and it obeys your prompt tightly, but push too far, and the image goes overcooked and garish. That's the whole control panel, really. How many carving passes, and how firmly to follow the words. Under the hood, the engine got upgraded too. The original noise predictor was a design called a unit. Newer models swapped it for a transformer, the same family of architecture behind the big chatbots, because it scales up more smoothly. Same idea, better engine. And one honest note, because this field moves fast. Most of the big generators you've heard of are diffusion models. Stable Diffusion, Midjourney, Flux, Google's Imagen all work the way we've described. But they're not all identical inside. As of 2026, OpenAI's latest image tool went a different route. It builds a picture more like how a language model writes a sentence, one piece at a time, an approach called autoregressive. So the careful way to say it is, most big generators are diffusion, but not everyone. So now we can knock down the 3 big myths in one clean sweep, because you can see exactly why each one is wrong. Myth 1, it collages existing images together. It can't. There are no image fragments inside it to collage. Every dot of the output was generated from noise. Myth 2, it searches a database and pastes the results. There's no database, no lookup, and no internet at the moment it draws. Just fixed numbers doing arithmetic. And myth 3, the big one, it stores all the training images. And here, the maths gives it away. Billions of images went into training, and what came out is a model just a few gigabytes in size. Thousands of times too small to physically hold those pictures.
it didn't keep the images, it kept patterns. Now, the honest asterisk, because good explainers don't overclaim. In rare cases, a diffusion model can spit out something very close to a specific training image, almost always one that appeared thousands of times in the data, like a famous photo. Researchers have deliberately coaxed memorized images back out. In one 2023 study, a little under 2% of generated images had a more than 50% match to a training picture. So it's not never, but memorizing is the rare edge case, not the mechanism. The normal job is patterns, not copies.
Which brings us to the question everyone's really here for. If it learned from millions of real pictures, is it copying? And here I have to be straight with you. This is where the settled science ends and a genuine unresolved fight begins. So let me lay out the facts plainly. The clean fact is that the machine learns patterns and styles, not files, closer to a human artist who studied thousands of paintings than to a photocopier. But the other fact is just as real. Those training images were scraped from the open web, mostly without asking, and the results can imitate a living artist's style. That's what people are angry about, and it's now in court. As of late 2025, in the UK, a high court judge ruled against Getty Images in its case against Stability AI, reasoning in part that the model does not store the training images, so it isn't holding infringing copies. Getty was given permission to appeal. Meanwhile, in the United States, as of 2026, an artist's case called Anderson versus Stability AI is heading toward trial, and it could land differently. So the honest bottom line is this: it learns from images and it doesn't store them. But whether learning that way, from scraped work without permission, is fair is genuinely not settled. We can explain the machine, the courts are still ruling on the ethics. Either way, you now understand what's really happening inside. It starts from pure noise, predicts and removes it, steered by your words in a compressed little sketch space, and there was never a picture in there to begin with. If you enjoyed pulling this one apart, subscribe and stick around, because next time we're opening up something you use every single day without a second thought. Same curiosity, brand new machine. No hype, no doom, just how it works. See you in the next one.